I need to sleep, but I'm riding. I'ma leave it open like a door, I'm sliding. Can you
Hello, everybody. Welcome back. All right, let's see. Today is December 2nd. We are finally in the last month of this year. We almost made it. We're almost there. Attendance. Where are you? 308. All right, here we go. Okay, let's I'll start maybe from the middle. Delia.
Here.
Okay. Kaylin. No. Wei.
Here.
Okay. Chansey. Okay. Sienna. Okay. Zach.
Here.
Okay. DS. Samantha.
Here.
Okay. Oni.
Here.
Okay. Gloria. No. Nikki.
Here.
Ashley.
Here.
Okay. Lucas.
Here.
Wendy.
Here.
Marco.
Here.
Ava.
Here.
Okay. Robert.
Here.
Leslie.
Here.
Okay. Yasmin.
Here.
Okay. Ariana.
Here.
Okay. Yusun.
Here.
Moranke.
I'm here.
Jada. Taylor.
Here.
Okay. Elliot.
Here.
Okay. So I'm missing, I know you guys have been trickling in, so you're not late, don't worry. Gloria. No Gloria. Let's see. So who's connecting right now? Let's see. Okay, so I don't see Gloria. Do I see DS? No. What about Chansey? Chansey? You emailed me. Kaylin?
I'm here now.
Okay, beautiful. And then Jada, I think I see you.
Can you hear me?
Oh, your voice is very like kind of like that weird robotic thing, but I could hear a voice, but I see you.
FYI, Professor, I'm in my work's office, so I can't really read or speak out loud today. So if you ask me anything, I'll type it in the chat.
Okay, that was Ashley, right? Oh no, Kaylin. Okay.
Yeah.
All right, good. All right, got it. And then DS, I think I see you now.
Yes, I'm here.
Okay, so do I have Chansey and Gloria? Okay. Let me know if they show up, okay? All right, guys, welcome back. So this is what we'll do today. We will, did I hear something? Let me know. You know, my voice is loud, so sometimes I just, you know, overcast everybody's video. Okay, just as a reminder, I know I said this a few times, but for you guys, because we're Wednesday, Friday class, the last day of class is December 18th. We are actually in that last month. You are in the final few weeks. So congratulations for making it this far. You just have a little bit more to go. You can do it. So the final will be on the 18th. Okay. And I'll make sure I'll give you extra time just for the peace of mind, but you know, it shouldn't be a test that takes longer than 2 hours. We will definitely take a minimum of 1 class and possibly 2 classes to do review. If we do 2 reviews, use 2 classes for reviews, that means including today, we have 3 lectures left, okay? And I plan on using all 3 lectures probably to finish regression. We started regression last time. There's a few more topics to cover. We will kind of go slow and I try not to overwhelm you guys, but regression is a very, very important topic. So we'll take our time and probably use this class and maybe 2 more, and we'll do a lot of practice problem in class, and then up to regression is your exam, okay? For you guys, I think it's okay to just keep the last day for the final, because that's just like the last week. But if you have any like really difficult, like, you know, just like so overwhelmed with a lot of finals and stuff like that on that week, you know, message me, maybe we can find something out. But if we were to find another time, then it has to be basically unanimous, right? I can't have just like 5 of you guys take it this time and the rest of you take it another time, right? That's just not a good idea. But let me know if it's just like absolutely, you know, a distraught semester and you just are having a hard time. Okay, let me know. All right, so before we go into reviewing of regression and moving on to some new information about regression, I'm going to put you guys in breakout rooms, and what I'm going to do is, it's kind of almost a silly concept, but if we were in person, what I would do is I would actually leave the classroom and let you guys do the student evaluations, right? Because, you know, you should be in kind of like your own space, have that privacy to do this. You are kind of in that space because we're virtual right now, but it's just to kind of ensure this even more. What I'm going to do is I'm going to create a breakout room for every one of you, right? So you're going to be in your own individual breakout room right now. And then I'm going to ask you guys to go ahead and take some time during the class time to fill out the student evaluations, which probably has annoyingly kept popping up whenever you log into Blackboard. So you haven't logged into Blackboard, go ahead and do that and open that up and do it for this class. I take those very, very seriously, and that has always improved my teaching, I think, every semester. So take your time to do it. If you have done it for this class, great. Use this time to maybe do it for other classes as well. If you're done with all the classes, then you just have a little bit of a break in the beginning, okay? Where is it, Professor? So I obviously, it doesn't pop up for me since I'm not evaluating anybody, but when you log into Blackboard, it pops up that you should be doing this. But Jada is also saying it's in your email. You must have, I'm sure you received many, many emails that you should do this evaluation, correct? Can all find it? Okay, so what I'm gonna do is kind of silly, but I'm gonna make a breakout room of 23 of you guys, because there's 23 of you guys present right now. So you're all gonna be in your own breakout rooms alone. Go join it and then do the student evaluations. And when you're done, come back to the main session where I'll be, okay? All right, apparently another email was sent this morning to you to do these student evaluations. So go ahead and do that. And when you're done, come back here, okay? I guess you don't have to, but for those of you guys in the main room, you should have gotten a little pop-up on Zoom to join your own breakout room, which you'll be in alone. Go ahead and join that, and then you can do your student evaluations. Though, you know, privacy just kind of by this inherent nature of Zoom is kind of protected. Oh, I see you, Chansey. What we're doing now is taking some class time to fill out the student evaluations that you've been getting a lot of email about. As in, you're the student and you're evaluating me. So if you can take some time to do that right now, that'll be super helpful, okay? And I will mark you as present. 308. Is also Gloria here? Nope, I don't think so. Okay.
Professor, can you hear me?
I can, but your audio, I think, is messed up again. So you kind of sound like a zombie-ish. If you're using, I feel like from my experience, if you're using headphones, that happens a lot, or earphones. So if you can just use your raw mic from your laptop, I think that usually works better.
Can you hear me now?
Yeah, that's much better. Yes.
Okay, I sent you a message on a chat. I don't know if you've seen it.
Oh, sorry. Yes, I'll look at it now. for those of you guys who are in the main room, if we finish regression earlier than I planned, and there's like an extra, let's say there's an extra class, would you prefer the topic of the misuse of statistics or data visualization? Not knowing exactly what those two things mean, what sounds more enticing?
I like the misuse.
Misuse of statistics? All right, Ashley too, and Delia. Okay, we'll get that. All right. So at least in this group, there's a.
I think data visualization. I think.
Jada's like, whichever's easier. I don't think either of them are like necessarily hard. It's just kind of like two lectures that I prepared to kind of add on to what we're doing. So as you know, and a lot of things in college is going to be like this. A lot of things are theoretical, right? I mean, the examples I always give is like the apples example, right? Super boring. Got to come up with better examples. And data visualization task, as well as the misuse of statistics, is to kind of make it a little bit more relevant to you guys and have more practical aspects to it. In my opinion, they're like kind of like the more fun topics, if you will. You won't be like necessarily you don't do any like calculations or spreadsheets or anything. This is kind of like an off topic, as in it's meant to kind of just enrich your knowledge, right? So either one I don't think will be difficult. It's to be low pressure and fun. Okay, so I'll like maybe review the misuse of statistics. And we'll see how our class goes, if we can incorporate that. If not, I'll just share the lesson with you guys. You can like take a look at it later. And that will be it. All right, I think that was a good 10-15 minutes. Let's see, has everybody returned? I think there's a few in the breakout room. I'm gonna go ahead and close, meaning that they'll have a minute to wrap up. Okay, and then we'll get started. All right, guys. Hopefully that was enough time. But if not, you can always obviously go back to it, I believe. I've never filled out one of those at FIT. Obviously, I actually have been a student. I did take a drawing class in the spring, so it was like half in person and half remote. But I don't think. No, I did fill. Oh, I think I did fill it out. Oh, I don't remember how I did that. Anyways, basically don't remember it. But I think you can keep it open and maybe do it later if you didn't have enough time. But we got to get moving. So I kind of close the breakout rooms, okay? All right, so the very first thing we got to do is we got to go back to the spreadsheet we were doing in class last time, and I have to fix a mistake. The dollar signs that I'm calling anchoring things down, it looks like I placed it in the wrong place, and I was basically just like brain farting. So I want to make sure I correct that, and we'll all correct it together. So in your Google Drive, because all of you guys made a copy of it, type in the search box, type in regression, slope, and intercept, or just type in regression, or maybe just slope or intercept. But if you type in regression, it should be one of the top spreadsheets that pop up. And it's technically, the title is regression, slope, and intercept. Your title might start as copy of regression, right? If you didn't retitle the spreadsheet. So go ahead and find that. So it will look probably like copy of regression. This is in your Google Drive, guys, okay? Slope and intercept. So find something that should be named something like that, unless you're one of those people who name every spreadsheet and, you know, have a certain format of titling it, maybe MA222 and put it in a folder, you know. If you're organized, you probably already know where yours is. Okay, so go ahead and open that up. And you should see, if you remember, you should see something like this that I'm about to share. Okay. And then make sure that my chat is open. Okay. So this is what we did last time. And remember, we did it in class and I made you share in class. Okay. So, and this will serve as a nice review as well. So let me just kind of zoom in a little bit more to be helpful. If this actually zooming works. Oh, here we go. It's a little bit delayed. All right. So remember what we started with was, I think something like initially we started with maybe 4 data points. I think that was kind of what we started with, right? We started with maybe like 4 data points. And then what we did with those 4 data points was we used some default functions in Google Spreadsheet to create our regression equation. Okay, so, you know, this was M and B were there. And then I said regression model. So, and then the answers to that is in the cells right next to it, right? So the slope was, we use a function called slope. And and then if you click on it, it actually highlights what we used, right? We used, remember, the Y variable comes first in the equation, and then comma, the range of the X variables, right? So we use the slope function to find the slope. And then we use the intercept function to find the intercept, right? And so if we write out the equation, it will be something like 1.7 times X plus 51.5 is what we got, right? So that's kind of like the Y equals MX plus B. I said to be more technical, if you want to be kind of absolutely very technical about it, the actual regression model will look something like Y hat. And I'll show you the symbol, how it looks. It's just like that caret that is on your calculator that goes on top of the Y. And if you wanted to be a little bit more exact to make sure that this is a regression model, which is not a line that has all of these dots exactly lined on it, though it kind of looks like it. Regression is a prediction model, right? That line is supposed to be based on some data. It's an estimated kind of like quote unquote average line where you can plug in a new number to find a prediction, right? So that's exactly what we did when we had this prediction. Here we go. We had 5, 6, 7, 8. So we wanted to make those predictions if we were to predict the sales in year 5, 6, 7, and 8. Okay. So this is where I want to make the correction. So what we did was, and you might remember this from when we did it earlier, and if you want to find where a good example of this is, you can go to Mathplosion, and we are going to be at 20, as of now, it should be 26.3. Okay, regression. So it's under the chapter called Regression, Slope, and Intercept. And in particular, the 3rd chapter in it, it basically shows you the same thing we did, right? So instead of reading this kind of statically, we actively did this in Google Spreadsheet. But chapter 26 will walk you through the steps we did last week, okay? So we had 4 kind of things that we already had, and then we wanted to make predictions, okay? Remember the number of years, so this cell and maybe the following cells, how many there are, those are the things that are changing. The things that are not changing, so therefore what you want to anchor is the slope and the y-intercept. So if, as you can see here, those are the ones you want to use this $ to quote unquote anchor it, right? Anchoring meaning that it doesn't change no matter what, right? So E2 is E2 right here, that's the slope. And then E3 is the y-intercept, right? So it's the M times, and this is the one that changes, X, right? That's a variable. So it'll change to 5, it'll change to 6, it might change to 10, whatever. So that can be here, but the M is anchored and so is B, the y-intercept. Okay, so that's what we're going for. We made a mistake, as in I made a mistake last time. So if you click on this, the 60, the one we made the prediction, we have the anchor in the wrong place, right? D9 is not the one that needs to be anchored, right? This is going to change because it's going to be D9 and then it's going to be D10 and then it's going to be the next one, right? So you need to get rid of these anchoring signs, which is the $sign. And instead the E2, which is a slope, that should be anchored. So make sure the $sign goes in front of the E and in front of the 2, okay? Just like that, the y-intercept should not change. So the $signs goes in front of the E and then in front of the 3, okay? That's why, and then you hit enter, which will still be the same number, but now you can use that thing where there's that square on the bottom right. You can put your cursor on top of it, and when you see that cross sign, you can drag it down, and now instead of an error, if you remember we got an error last time, now instead of an error, it will actually calculate for the 6, 7, and 8. So if you click on it, the equation now applies where the E2 and E3 is anchored, as in it stays the same, but only the X changes to D10, D11, D12, okay? And then you can copy that over, and I think it will transfer over if you transfer it over here, okay? So that's what we did. So these were the predictions. So these are, you know, not the initial data we started with, but this is the predictions that we used later after we calculated the slope and the intercept. And just remember that what you anchor is the one that doesn't change, and the X variable, for example, should change depending on what the X is. Okay, so that should be corrected. Make sure that is corrected. And once it is corrected, please everybody go to share and share it with me one more time. Okay, so I can have the updated version. So you'll type in Maria _Huang, okay? And then share it again. It might show that it's been shared with me, but go ahead and just share it one more time so that I get that, notification, okay? All right, so make sure this is updated and the right $sign are in the right place, right? We're anchoring the right numbers. Right, any questions regarding that part? We've done this kind of like quite a while ago, and that time we did it correctly. We just somehow didn't do it quite right this time. Okay, make sure you do that. I'm gonna check my email and see what kind of sharing things I get. All right, only got it from Robert, Ashley, Ava, and Nikki. I refresh. Now I have from Zach, Samantha, and Elliot. Make sure you reshare with me. Now I have it from Delia and Ariana.
Professor, mine's just loading. So whenever it goes through, it'll go through, but I did submit it.
Got it. Sounds good.
I have like no service down in the basement.
And then these are just the new like bane of existence these days, right? I got it from Yuzhan, I got it from Yasmin, I got it from Leslie. I got it from Wendy. Okay, let it trickle in. All right, so we did that. Attendance, we did final, we did the breakout rooms, and then we fixed the anchoring. Okay. And then we reshare. Awesome. Show my spreadsheet again. Yes, of course. Here you go. And then if you want, I can highlight that one that we just fixed. And maybe I can zoom in a little bit more. There you go. All right. All right, So if you guys are one of those who already shared and you're good, go to Blackboard and then go to content and go to regression. And you're going to see, I think it says regression, like slides, additional or something like that. It has those word combo of those words. It's like a PDF, I believe. Go ahead and download that. That's actually from my upper class, MA222, the upper level stats class. And we do kind of extensively go into regression. And we use a machine learning algorithm actually to make some predictions. But anyway, some of the slides are relevant. So we're going to go through some of them and learn about this new concept correlation. And then after that, we will like do some, you know, spreadsheet stuff together. Okay. And I think that will be a wrap for today. Okay. Okay. And if you got that PDF, basically it's slides made into a PDF. If you got that ready, go ahead and type in PDF in the chat. Okay. And so when enough of you guys are ready, we'll get started with those slides. Okay, I'm going to also open that up. Very good, very good. Also, just as a general piece of advice, guys, so, I mean, we didn't know and now we do, but things are going to still be remote in the spring. I'm still hoping that it's kind of like my dream these days. It's like we start remote and like a week or 2 weeks in, like the vaccine, we all just get distributed. It's like, psych, we're back in person. And that's kind of like my wish right now. Hopefully that happens. But anyways, if that doesn't happen, if we stay remote, I would like to recommend, guys, try to, if you can establish a stronger Wi-Fi connection, or if you can like use your Ethernet instead of the Wi-Fi at your home or wherever you are at, try to establish kind of a stronger connection just in general, because obviously, you know, everybody's going through a lot and things will stay remote. So the foot traffic is going to be heavy and stuff. And the bandwidth is limited, right? This country says it has 5G, but it's nothing close to that. But also try to get in the habit of maybe being more prepared for the class. And when I say that, be ready so that you can have your cameras on, right? So I'll give you a good example. Ariana has been amazing, and every class she has been has her camera on. The thing is, guys, we are all humans, right? And I'm a teacher and I'm imperfect and I'm human, meaning I'm emotional too, and I'm sensitive, et cetera, meaning that it is more heartwarming to see your faces. And if Ariana, for example, has her camera on every time, Ariana's doing perfectly fine, but let's just assume she was at the cusp of an A-, for example. I am so much likely to just give her an A, just because I know she's been here, she's had her camera on, she's been active and like nodding and doing all of that, and I could see the participation. I have pretty good memory, as you guys can probably tell. So I know who's participated in the chats and stuff, and I know who has been there, I know who has been absent, I know who's more talkative and more participating, all that kind of stuff. But it just helps, right? Because as some of my other like students have realized in my class, actually, that they were in the same class, but they didn't realize it, because they never shared their screen, or they never bothered to learn each other's name and not interact. So, and then they're like, and then they said, apparently there's a class where the professor never turned her camera on. And they're like, I don't actually know what my professor's face looked like. And they're like, it's very disturbing. I'm like, hello, right? So I'm the same. If you feel that, I'm going to feel the same way. Okay. So just moving forward, if you can, and if it means that you need to like clean up your hair, blow dry your hair, or whatever it needs to be done, maybe try and do that so you can get in a habit of like, I'm going into class today, right? You know, like you used to in person. So you're more kind of ready to get in the mood for studying and maybe have your camera on. I swear to God, that having you guys engage and turning your camera on is the hottest topic we are talking at every faculty meeting over and over and over again. How do we get the students engaged? How do we get the students engaged, right? And the reason is because we don't know if you guys are engaged, if it's just a black box, right? I can make sure that you guys are engaged. I make you guys read. I make you guys answer my question. I make you guys type things in. Super, super annoying, right? But the reason I do this is because I can't see you. I don't know where you are. And it is apparent when I call on you sometimes. Sometimes there's no answer. Knock, 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 right? So just moving forward, if I feel this way, and I'm pretty aggressive in terms of trying to get you guys to talk to me, right? If I feel this way, I can only imagine how other professors feel like when they're looking at a black screen with just like, you know, names on it. And especially in Blackboard Collaborate, I heard you can only see 4 people, which is like absolutely the most horrendous interface. I don't know why that's even a thing. So, you know, it's gonna be frustrating because we're human and like our job is to teach, right? And how do we teach? We get you guys engaged, right? You guys answer me or question me, throw things at me and be like, Professor, you're wrong. This is like how you do this, you know, stop and like explain this better, right? That's how I know you guys are there. So just moving forward, since we do know that we're gonna go in the remote session, I don't know how fashion design studio-based things are gonna be. I think they're trying to make it a little bit half hybrid. But since the default will be this situation, make sure that you kind of go in, you know, doing your part to make that interaction a two-way street. Trust me, it can only help you with your grade. Trust me, I can guarantee that for you, okay? So just keep that in mind moving forward, since we do know we're going remote. Okay, it can't hurt you, that's all I'm saying. All right. Okay, where were we? Okay, yes, if you have the PDF open, let's go ahead and read some of the slides together. Documents. I swear to God, I had this open. Apparently, it disappeared. Lecture slides, regression, updated, that's right. Okay, so we didn't really use the phrase simple linear regression too much. Because we probably won't get to multiple linear regression. We only been using the word regression, right? But simple linear regression, all it means is that you're gonna deal with one X variable, guys, right? Which is what we're doing. So that's all that's referring to. You don't actually have to memorize that phrase or anything like that, but that's what that means, simple linear regression, okay? And it'll become obvious as we talk more about it. Okay. Simple linear regression, first paragraph. Can, let's see, Ariana, can you start us off?
Simple linear regression is a statistical method that allows us to summarize and study relationships between 2 continuous variables.
Very good, 2 continuous. So we're always dealing with quantitative variables, and it's a statistical method that allows us to summarize the relationship, right? The X, which you might be familiar with, and another word that's familiar with you guys is independent variable. Another word we use is predictor variable, because remember, we're making predictions. So the prediction is actually going to be the Y, but predictor, OR, that means that this is facilitating prediction. So it's helping to make the prediction, and X is going to help you do that, right? With the information of X, we are going to make predictions, which is the Y. So therefore we also call it a predictor variable. This is emphasized in color because when you do machine learning, like artificial intelligence stuff, this is kind of like the terminology we like to use. X is the predictor variable and Y is either the response variable or prediction, okay? In our case, independent variable and dependent variable, which should be already familiar to you, is fine. Okay, so we're dealing with one X and one Y, simple linear regression, or just regression is fine. Okay, so the Y variable again is reserved for the variable we want to predict. This is the actual prediction we're going to make, just like we did in that spreadsheet with year 5, 6, 7, 8, right? And the X variable is being used in order to make that prediction happen, right? To help it, to facilitate it, predictor variable. Okay, so before we did already talk about regression, but sometimes you might be like, so, well, like, how do you know when you have a data set whether you should be thinking about a regression? Usually what we like to do is we first like to establish, we like to define the relationship between these 2 variables, right? And the one of those relationships that is commonly used in statistics is called correlation, okay? So the first 2 bullet points, Oni?
A scatter plot can be used to show the relationship between, the relationship between two variables. Pearson's correlation coefficient is used to measure strength and direction of the association linear relationship between two numerical variables.
Very good. Okay, so the long term, the official long name is Pearson's correlation coefficient, right? It's a very, very long word. All you really need to know that it is a correlation. Okay, so this is determining the strength between X and Y. Okay, and maybe they're not initially called X and Y, maybe they're called year and sales, right? Whatever those two variables are, we're going to see how strongly they relate to each other. Okay, so even though we are dealing with quantitative, like numeric number variables, I kind of give you this example down here. That's more of a qualitative description. But if you want to kind of think about it this way, it's like the correlation between you and your brother or sister is very, very high, right? Or like you and your parents. However, the correlation between you and your cousins are a little bit further away, kind of like blood-wise, right? And the correlation between you and somebody who randomly walks down the street and just passes you by is going to be a very small correlation. And then somebody maybe who is living in the state of Washington, because they haven't really passed by you ever, is going to have even a more significantly smaller relationship with you, right? But it's that strength between two variables, two things that we're trying to measure, and that's called a correlation. You don't really do it between people, you do it between two numbers. But if you want to kind of think of it that way, that's the kind of example I wrote there, right? It's probably not the best example, but that's what it means to kind of define how tightly are they related to each other, okay? However, you got to be careful when you use the word correlation, because that doesn't mean it causes something, right? So let's say we have a variable A and we have a variable B, and they're very strongly related. And that is determined by this coefficient. There's a number that tells you the strength. And the highest number is 1 or -1, because you give it negatively related or positively related, right? That just think about the direction of the line when you draw y equals mx plus b. It's kind of like going positive or negative. That's kind of like the idea. So it can be a very strong relationship, strong like positive or negative, but that does not mean, that does not guarantee, for example, that A causes B, okay? All it is telling you is that they're very tightly and they're tight and close to each other. Doesn't mean you have a causal relationship, okay? So this is kind of actually a very commonly mistakenly used thing in social media and all these different places that quote causal effects and correlations. With a lot of times, a lot of things are going to have correlations, right? They're related to each other in one way or another. And then often from that, people conclude, right, infer and say, oh, therefore A causes this, A causes B, right? That's not necessarily true. If you want to prove causality, you actually have to go through a rigorous experiment to prove it, right? Just because a lot of times if A happens, then B happens, does not mean that that causes this, okay? Sometimes
I have a question.
Yes.
So does this mean like, if you go to a concert, like the amount of people you bring doesn't affect the amount of people that go?
If you go to a concert?
Yeah, if you go to a concert, like say if I bring 4 people, that doesn't mean that anybody else is gonna go to the concert. Like,
Okay. Yeah, I think that's a pretty good example. So for example, let's say that Chansey has like your social influence is so strong. So when you tweet, say that, oh, this new like artist came out and they're showing they're having a concert here. So you tweet it, and then once you tweet it, like a lot of people are gonna go, as opposed to people when they didn't know it, right? So then there's a strong relationship of your presence on social media that will lead to an increase of people attending that concert, right? However, that does not prove, you're absolutely correct, that does not prove that your tweet caused these people to go to the concert. It could have. That is definitely true. That's a possibility, but that alone does not prove that. The only way you would be able to prove the causality is if you ask every single one of the people who came and ask, was it Chansey's tweet that made you come? And then they say yes. Then you can prove that. However, just by looking at the numbers, like you tweeted and then you looked at the number of people who attended the concert, that will not prove a causality. That definitely will show you a correlation, because maybe with your tweet there, it seems like there was an increase of number of attendees, but that does not prove causality. So that is absolutely correct. Good example. Yeah, I kind of expanded on like what you were asking, but yeah, that's exactly correct. And you can see from that particular example why people might conclude that there's a causality, right? But that doesn't effectively and sufficiently prove that there was a causality. It definitely seems like there was a correlation, and correlation is easier to prove than causality. So you know how, you know, we say like the more you smoke over the years, the more likely you are going to get lung cancer, right? That's a typical example of a correlation, right? However, you don't know for sure that every person who got lung cancer because it was due to smoking. You can't prove that causality like definitively. You might be able to run some experiments to prove that, and but you can't just assume that for every person who has lung cancer. And it's true, like people do get lung cancer without having smoked a single cigarette in their lives, right? So those are the things that we need to be careful with, and that kind of falls under that topic of the misuse of statistics. I was asking some of you guys when you got out of the breakout room if like that would be something of interest. This is one of those examples of where statistics is misused, right? It's just a correlation, not a causality. But that also means sometimes when there's a high correlation, there's also a causality. It's just not always the case. Okay? Excellent question, guys. Okay, so we first kind of could look at correlation before we jump into regression. But you can jump into regression right away too, right? You always kind of like try something out and see what happens, okay? All right, before we proceed, this is kind of taking us back a little bit, a step back. I want to make sure that we understand what regression, what this prediction is. So we're going to talk about what we're not talking about today, and that's called a deterministic relationship. It's kind of like a hard word, but you don't have to memorize it. But what you need to know is that deterministic relationship is basically what you learned in high school, okay? And that's exactly y equals mx plus b. So every data point that you have available will actually be on that line, on that y equals mx plus b. That's a deterministic relationship, right? The x will determine a specific y. The x and y have a very specific location, and it all is lying on top of that line, okay? Everything that you know, Fahrenheit, converting Fahrenheit to Celsius, Celsius to Fahrenheit, that's a mx plus b situation, right? That's a deterministic relationship, right? Anything that you learned in high school probably to get the circumference from diameter, Hooke's law, Ohm's law, Boyle's law, all these things you learned in science, these are all deterministic relationship, right? The equation exactly describes the relationship between the two variables. What we're doing today, as well as last week and like probably another lecture or so, is not an exact relationship, but is what we called a statistical relationship, which is why we're learning it in this class, right? It's an estimate. It's not perfect, okay? So what it's gonna look like, it's gonna look more like something like this. Okay, so the sales and year example wasn't maybe very clear because there's only a few examples, but this is a very good example of what a regression line looks like, right? All these data points are scattered around that red prediction line, and look at the corner, y hat. That's what I mean by the hat, right? That's actually statistical, in statistics, that's what we call it. It's not like I made it up. We say y hat, and that is to indicate that this is not a deterministic relationship, okay? This is a statistical relationship, and what this is saying that this is a prediction line, a regression line, and a negative prediction line, right? It's going, as the x increases, the y is decreasing, okay? If you're more specific, you can see the latitude is on x, And then skin cancer mortality, deaths per 10 million is on the y-axis. Who wants to take a stab at what you can conclude from this graph right here, from the relationship you see between latitude and mortality? What do you guys think?
As state latitude increases, skincare mortality decreases.
Very good, right? As you're kind of higher up, so Northeast and Maine and us, right? The mortality rate due to skin cancer seems to decrease, right? Very good, very good. If you want to extrapolate a little bit, I think this is saying that you should probably not retire in Florida because you might get skin cancer. It is true. Again, not a causal relationship. We don't know that for sure, but we do know from statistics that a lot more skin cancer, there's a huge amount of skin cancer doctors, like oncologists in Florida than in any other state in the United States, because a lot of people tend to be outside and are exposed to skin a lot more, which, you know, long extended skin exposure under the sun does cause skin cancer, right? There is a causality there that has been proven scientifically, right? So this is more of a correlation where we see that it does seem like the lower the latitude, so basically warmer the state is, probably that means a lot of people are more outside and been exposed to exposed to the sun longer periods of time. There's a higher skin cancer mortality rate, okay? Things like that. So this is what we mean by, this is a regression, right? This is a y-hat, a regression, meaning that it's a prediction, right? There's no data point from our data that's available where what the skin cancer mortality rate would be when the latitude is, let's say, 28, right here where my cursor is, right? But I can plug that in. I can plug that into this regression line and it will give me an estimate of what might be the skin cancer mortality rate if the latitude was that, right? That's what this is helping, and it's helping you to make that prediction. Yes, Marco.
I have a question.
Yes.
Okay, so I'm just looking at this, right? And then I was thinking, would it be possible to plot this as a standard normal distribution?
Yeah, you could. You definitely could.
Because like you have your outliers and then the majority of the data cluster toward the middle. And, you know, like a standard normal distribution, sometimes it's not exactly accurate. And then like with like, I forget, was it the something regarding the confidence level? Like you take the means of each one and then you plot them to get a more accurate standard normal distribution.
Absolutely. All of those things that you're saying are possible, right? So that's the beauty of statistics, is that this is one way to look at this particular data set, right? There are other ways to probably look at the data set as well, right? Maybe what you want to expand on what we did here, and then you collect more, and then you take the averages of everything and plot it. Remember, if we take enough samples of the population, right? This is not the data points of every single person in the entire world, which is the population. Then maybe you get several samples and you repeat that and take the averages and plot it. And then if you have enough samples, then you will get to a standard normal distribution, right? That's one way to describe latitude versus mortality. Two, you can collect other data to describe things, all kinds of things. And then from that, as Marco, you said, you might be able to say, with so and so much confidence, we believe that the average skin cancer mortality rate is in between this and this, if you live in a latitude that's around, I don't know, 38 or something like that, right? So you can describe this information in many different ways, including all of the things you mentioned. Excellent. Look at you guys making all these connections, giving me examples that are better than apples.
Also, if you look at this graph, you can be like, and so, someone asks you like, on a scale of 1 to 10, how bad is your skin? And you're just like, Florida.
How bad? Florida. Yeah, that's, I haven't seen great. Well, okay, so I think it's also, it's also duration, right? There's a lot of young people in Florida who have like, you know, what we might consider like glowing tan skin color, and they've been outside in the skin, but they're just young, right? So they look great. So, but if you continue to do that over 10 years, I'm sure it won't look that good.
It won't look
I was
good.
in Hawaii this one time, and this guy, I bet he just lived on the beach his entire life. I've never seen skin that it's not like I touched it, but I looked at it and it was just like leather thick. I could not even believe that was a human being. Like you could just tell how thick it was. I was like, oh my God. I feel like I would need like a huge machete to cut like his skin if you were to make like a leather bag out of it. It was insane. And I'm just like, I am surprised he's alive. So if you're in these areas and you're constantly out in the sun, I think something does happen to your skin. So don't overdo it, right? We all love to be on the beach and be exposed in the sun, and vacations are good. But you know, anything excessive is too much, right? Imagine the lotion you need to use. Yeah, so there's lotion where, you know, you can use sunscreen to protect yourself, or there's lotion that like just basically makes you tan more, right? The things we do to ourselves is just like, incredible. Anyways, I still remember how he looks. It was just like, I've never seen skin like that on a human being before. It was like insane. Anyways. So, you know, be careful, okay, guys? I mean, we're all inside now, so we're definitely deficient in vitamin D right now, but, you know, don't go too far is what I'm saying. Okay, let's see. So one more thing from these slides. These are some of the types of relationships you can kind of define. And this is kind of generic, right? This could be, this is generic in the sense that, you know, there's no specifics, but you can see that the black line right here, which is indicating a regression line, kind of like quote unquote, remember quote unquote, that average line, when the dots, the data points are closer to the line, then that means we have a strong relationship, right? Because if we were to kind of describe the regression line as an average, then these data points are not too far from the average. It's very close to the average. So that's a strong relationship. And something here would be a weaker relationship, right? Because we call this deviation, how far away the data points are from that regression line. The deviations are farther away, and that's not good. That's a weaker relationship. But both can have strong positive or weak positive, or strong negative or weak negative relationships, okay? All right, so those are the types of relationships. It might not look like it initially, but these are types of relationships where there is no relationship whatsoever, right? Even if this is like tight to that black line in the middle, but that means there's no relationship, right? Because that's when a slope basically does not exist, right? So that's the types of relationship when there is nothing at all. In correlation, that would mean that the correlation is zero. That almost never happens because we live in this complex world. There's always some tiny relationship if there is something. And also because we live in a complex world, there's never a perfect relationship either. Unless if I were to use the human to human example, you and yourself, basically you and a clone of yourself will be a perfect relationship, right? Because you're exactly the same. So that would be a relationship like 1 or -1, a perfect correlation. But anyways, those are some odd, ideal, like weird examples. Okay, so that's it for that. So only the slides that I covered are kind of relevant to our topics, right? And the rest you can just ignore. All right. So now that we have kind of reviewed and added a few more concepts, like correlation is kind of new. Remember that correlation is just correlation, nothing more, nothing less. No causal relationships are there. Now let's go to mathplosion, okay? So if you are one of those people like me and have this in a little bookmark, so go ahead and just click on it. Or if you don't, I will give you a link right now. Just give me a second. We're going to start with the chapter that says, is this a significant linear relationship? So if you don't have access to it right away, just click on that link that I sent you in Zoom and we'll talk about significance, okay? So another phrase I want you to kind of become familiar with, and this is used a lot in research, is there a significant relationship? And specifically, we sometimes ask, is it statistically significant, right? Meaning that, can you run like maybe statistical analysis, and with a high confidence level, basically, can you say that there is some relationship? It's not by chance, right? It's not like, oh, it was a 50% chance that happened, like flipping a coin, right? Is there more than a chance that this relationship exists, and that if there's some kind of linear relationship in particular, right? There's a line that we can draw, okay? So we're gonna see how we can assess whether there is a significant relationship or not, okay? All right, so let's see some examples here. Suppose we have the following data for an ice cream vendor involving the temperature on a given day and the gallons of ice cream sold that same day. So temperature is about 73, very nice weather, I miss so much. And then this particular ice cream store maybe sold 110 gallons of ice cream, 75, and then 77, okay? So we have 3 data points, which is not many, and we are going to draw that line, okay? We're going to plot them, and then let's pretend we're kind of rookies and we don't really know stats well. So we're gonna just go ahead and, take a chance and go ahead and draw a regression line, right? We're gonna use Google spreadsheet, use a slope and intercept and all that kind of stuff, and we're gonna draw this line. Okay, because we have now software applications that do that for us automatically, which is great, right? So we drew this line. All right, and as you can see from that, we got this negative M, and then we got something like 197-ish of a slope. Sorry, not slope, what is that? A y-intercept, okay? All right, should we use the regression line? These lines, Yasmin, can you read that for us?
Should we use this line for predictions? We should probably be suspicious. The regression line has a negative slope. This says that as temperature goes up, the gallons goes down. That sounds wrong, actually. We expect it to be the other way around, right?
Right, so we're in particular, because we have the context of temperature and ice cream, and from your anecdotal experience, usually some ice cream places have better sales in the summer, right? Even though, having ice cream usually makes you more thirsty, but that's not really the point, right? It's delicious and it's great and it's cold initially, so people have ice cream in the summer. Personally, I think ice cream tastes way better in the winter because it doesn't melt all over, but that's a personal preference, right? So if you have the context of your data, it is okay to refer to your common knowledge and be like, I don't know about that. That doesn't really sound right, right? So hopefully you do have more data that you can plot. And if that is the situation, you definitely should be a little bit suspicious if you only have a handful of data points. And then look at this. If you had more data, this is what the trend looks like, right? Because these two kind of situations might have been an anomaly versus this one, where there was a little bit less sales than that time it was 73 degrees, right? You can't really find a trend when you have such small of a data set. So you want to make sure that when you do these regression lines, you are relatively confident that this is actually the trend that it should be showing. Even if you went up to 10,000 data points, that this will still kind of be the trend. Okay, so this sentence, Delia, please.
Okay, now things look quite a bit different. In fact, the rest of the data makes it clear that our original model, based on just the 3 data points, was not really representative of the rest of the situation.
Very good. And we use the word model a lot in stats when we're referring to like an equation, okay? So this like line is what we mean by when we say model, okay? This is used a lot in stats as well as machine learning. We say machine learning model or machine learning algorithm. It's kind of used interchangeably, okay? So now that it's clearer that we see the full picture, that these data points are not enough to get the whole picture, right? It's kind of looking at the trees and not the forest, if you will. All right, so taken by themselves, the 3 data points we started, looked like there might have been a downward trend, but that was not actually the case, okay? So this is why you have to be a little bit careful, and this is also under that purview of misuse of statistics. If you don't have a better picture of the bigger data set, it is often that you could make the wrong inference, wrong conclusion, and that's definitely very, very dangerous, right? It might not be dangerous if it's just like, oh, how much ice cream you sold, but in something that has to do with medicine, for example, that's something you do not want to make a wrong conclusion about, right? Okay, 2 first paragraphs. Elliot, please.
It turns out that there is a calculation that will tell us when we have situations like the above, either too little data or maybe no detectable trend given the amount of data. This is called the overall significance test of the model, and it uses a p-value. When the p-value is smaller than 0.05, we say that there is a significant linear relationship between the y variable and the x variables.
All right, very good. So you're familiar with this p-value. We talked about this a lot when we were doing hypothesis testing. It is that same concept, okay? But just brought up in the context of regression, okay? So we'll get to that. We'll get to what really does it mean in the context of regression versus the context of hypothesis testing. Just hold on that for a second. The next 2 paragraphs, Lucas, please.
Without getting too technical, we will use this to mean it's okay to go ahead and use the regression line for predictions. If the p-value is not less than 0.05, then it is probably not okay to proceed to predictions using the regression equation. Usually, you are in a situation like above, with either too little data or no discernible trend for the data that you do have. You might be able to go back and get more data and redo your analysis.
Very good, right? So simply put, very, very kind of simply put, the overall significance test, we call it a significance test, is determined by this particular p-value. Remember, when we did hypothesis testing too, the default significance level was always set to 0.05, right? This is where that comes in. Usually, even though I told you it's controversial, for decades and decades and decades, we have accepted this as one of the acceptable thresholds where we determine if something is better than chance or something is basically a coincidence and it's by chance, okay? So if the p-value is less than, remember that's when we rejected the null hypothesis, which is a good thing, right? We want to do that. If the p-value is less than 0.05, that's a good thing, right? We have reached a point where we can say, this is more than chance. There's definitely some relationship here, and we can dig into these 2 variables more in depth and maybe do a regression, right? Meaning that the X will definitely facilitate to make a prediction of the Y. There is a strong relationship there. If the p-value is equal to 0.05 or greater than that, then usually it's not a significant linear relationship that you will end up with, and we don't want to proceed with the regression, okay? So this is kind of like, in a range of things when we do conclusion for hypothesis testing, this is when you get strong evidence or even more strong evidence to reject the null. Those are those 2 scenarios. And anything that we, that in the textbook that said, oh, we have some evidence, we have moderate amount of evidence, we don't have that much evidence, all of that falls into the second part where the p-value is equal to or greater than 0.05. So yes, it is the same thing that we talked about in hypothesis testing. We just use it kind of like a little bit differently, right? In the hypothesis testing, that means that we reject the null hypothesis, and that means we are more likely to accept the alternative hypothesis. In this particular case, we mean that when the p-value is less than 0.05, that means, oh, there's probably a significant, specifically a statistically significant linear relationship. So yeah, let's go ahead and do regression. Or if it's equal to or greater than 0.05, that's like, I don't know if I'm confident to say that there is this kind of strong linear relationship, right? I'm not so sure. Maybe I have to collect more data. Maybe I have to revisit my research questions, okay? So that's kind of like the simplified version of how you would interpret those p-values, okay? And that's enough for now, okay? That's enough for today, for right now. What I do want to get your attention to, if I have this open, God, why did everything close up in my Just give me 1 second. You guys are my Wednesday, Friday class. That's right. Oh, it's Google spreadsheet. Yes. I think I remember why it disappeared. Slides. Do I have any fashion design students, guys? Anybody who has a major that probably will involve a studio-based course next semester? Maybe fashion design students don't have to take stats. I don't get them often. Okay. All right, so I want to bring you to this. Okay, so this is kind of like reviewing what we were just talking about in terms of the p-value and stuff like that, okay? So remember the null hypothesis from hypothesis testing. Null, you know, if you look up the actual word on a dictionary, it means zero, right? Nothing. So the null hypothesis states that nothing new is happening, right? The old, whatever the previous status was, previous state, status quo was, that's going to be that's going to continue, right? The no changes have occurred. So remember in the NBA example that we did in class, there were rules that were implemented so that the scores would go up. However, the null hypothesis states that the scores do not go up. In fact, we say the scores equaled whatever that number was, 185 or something, because that was what the score was before, the average score was before, right? So by stating that the null hypothesis equal that number, it's saying that nothing new happened, okay? And what we want to be able to do is we want to reject that, because the whole point of making these new rules is so that the average score would go up, right? And we want to do that when the p-value reaches a certain, it goes under that threshold of 0.05, right? In the cola sweetness example, you rate the cola before storage, and let's say it's a scale of 1 to 5. I don't really know what scale they use. And it was 2 before storage. And then after storage, you tasted the sweetness, and assuming everything else was the same, you also state the sweetness was 2, right? 2 minus 2 is 0. So we stated that the null hypothesis was that the cola sweetness was equal to 0, meaning that before and after, no change happened, right? So nothing new happened after storage, right? That's how we would determine what the null hypothesis was equal to, right? It's usually a value, but that value is an indication that nothing has changed from the old to the new, okay? In regression, it's the same concept, but just slightly a different nuance. What the null hypothesis basically means in regression, it means that there is no relationship between the dependent and the independent variable, okay? And no relationship is basically a very, very weak relationship, if you will, right? There's hardly a case where there's just zero relationship, but basically, theoretically speaking, that's what we mean by the null hypothesis in the context of regression, okay? And again, if there is like a no relationship or very weak relationships, that's usually indicating that the p-value is equal to or greater than 0.05. In that case, we don't want to proceed with the regression techniques, right? We don't want to use the X to make a prediction for Y, because it probably means that it's not going to make accurate predictions. We don't want to use the wrong information to make wrong predictions. That's definitely a dangerous place to be. Okay. All right. Questions so far? I'm trying to determine if this is a good significant relationship. And if you got a notification that some regression spreadsheet was due, that is not true. I'm having just a hellish of a semester with Blackboard and Lumen and everything just sending announcements at times that I don't want it to. So if that were the case, always follow what I say in the class, okay, guys? So if it said something was due today, I apologize. Nothing I think was due today. Or was it?
Professor, what happens if we did it? Because some of us thought that it was due.
What popped up as maybe I did assign something? Who remembers? Who has good memory?
I thought you did assign it. It was like 3 spreadsheets and like 1 Google sheet.
Oh, I did assign that. That's right. You guys are the Wednesday, Friday class. Yes. So you should have gotten a notification. Ah, that's right. It was the other class that was Monday. That's why I keep getting confused. Okay, yes. So inside content, regression. So the in-class activity we did, and then we fixed it today, and that's all shared. And if I got that in my email, you're all good, right? And then we did the regression questions assignment, right? That was the Google spreadsheet. And if I open it up, it was only like 3 questions, correct?
Yes, that's what you said to do.
Yeah, perfect.
Yeah, I think so.
If you did that, that's good. Yeah, if you did that, that is excellent. Yes, that was due today. And then remember, if you haven't, go ahead and finish it up. The solutions for that are available in the same place where it was assigned. And remember, there's regressions, questions, submissions. So that should be submitted right there as a PDF or an Excel sheet, okay? Yes, that was assigned. And then the line is, this one is not assigned yet. Okay, perfect. Okay, so if you did that, you are good. You are very, very good, and that was assigned. If you haven't done that, just make sure you get to it and finish it up, okay? What was, Ashley, were you saying that besides that spreadsheet, did I assign one more thing?
No, I'm pretty sure it's just the regression spreadsheet.
Okay. That's what I remember now too. Okay, perfect. So if you did that, that's great. If you have not, make sure you finish that and submit, right? Always submitting is better than not submitting, okay? Even if I already provided you with the solutions. Okay, good. What we will do is, do we have enough time for this? What do you guys think? Okay, so I'll prompt you with the thing that we will basically finish next class. I think we don't have enough time, so I'll prompt you. So what you're gonna do is, I'm just gonna give you basically like a preview of what we will dive into right away next time, okay? So in Blackboard, in content and in regression, underneath where it says regression slides additional, where you clicked on and download the PDF that we just went through, there is, I'll get rid of that mod 6, but mod 6 spreadsheet assignment, rent the runway setup. You might see that. Go ahead and open that up. Okay, so that's what we're going to do next time. I wanted to possibly finish that today, but I just don't think we're going to have enough time. So I'll just set it up for you guys and we'll read this and then you will know what we're going to do. Okay, so I try to make it a little bit more fashion oriented. So I did something with rent the runway. Okay. All right, so if you open it up, and you might actually already be familiar with this company, but it's a company that provides clothing rental as a service, right? And I think it's supposed to be like kind of fancier clothes that you wouldn't necessarily purchase. And even if you did, you'll only wear it once or twice in your lifetime, right? They also have one-time rentals that you can rent in addition to subscription service, right? Subscription service is kind of like, not the newest thing, but it's been around for a while where people are loving to do it, right? Or at least the companies are kind of insisting on doing it. And it's like you pay a monthly fee and you just get unlimited access to whatever the products they have. Okay, you can even search on their website and see the one-time rental pieces where they give the price the item retails for, as well as what their one-time rental fee is. Do you think we can predict the rental price at Rent the Runway of something if we know the retail price of the item? So that's the question. And this is not like a ridiculous question because Rent the Runway people are going to have to determine kind of like this beautiful optimal price that is, you know, cheap enough for the customers to be like, okay, that's something I could pay for to have to be able to rent this for 1 day or like 3 days. and not kind of push the limit and kind of push away the customers and make them feel like, whoa, that's like way too expensive. Even if it's just a rental, like I'm not willing to pay that much, right? They have to find that optimal price. So this is something that they would be interested in. And obviously they have to make a profit, right? So it's that kind of fine line, finding that sweet spot where the customers are like, okay, I'm willing to pay that. And also they're making kind of like a side profit that actually helps the company as opposed to losing the money, okay? So I extracted some data from Rent the Runway. So if the retail price is $150, for example, the first one, then the rental is for like $30, like the one-time rental, okay? Not like, I don't know, for an extended time or subscription service, right? And then if it's like 375, it's 45. If the retail is 550, it's like 85. So that kind of makes sense, right? The more expensive the retail price is, the more expensive the one-day rental should probably be, okay? So there's all this data, and we're gonna bring this into a spreadsheet and do something with it, okay? So for example, some of these things that we covered, right? These are the examples with this particular priced item at the retail price. This is the rental price for one time. And then if you scroll down, you will see the scatter plot of the data. I'm assuming you guys are looking at this because I guess I thought I was sharing my screen. But yes, so rental versus retail at Rent the Runway. This is the scatter plot you see. So the retail is on the x-axis, and then the rental is on the y-axis. Why? Because based on the retail price, we want to see if that is a good indicator that will help us make a prediction on what the rental price of that clothing item should be, right? There's already things that are already available, but there's new clothes all the time. And so they're going to continuously have to make this rental price available for all these new items that keep coming in, right? And you want to find that sweet spot, as I said, in terms of all these like different kinds of runway clothes, okay? So this is what we plotted from the data that was above. There's a little bit, something's a little bit odd. Can you guys spot what's a little bit odd? Anybody see something that you're just kind of like, I don't know what that is?
I see like a cluster of data like towards the bottom, and it's just like in a straight line.
Yeah, very good, right? It's a little bit like compared to the other ones that are kind of nicely spread out here and there. You see like a cluster of them kind of all at the bottom as if they're they have no gravity affecting them or something like that, right? A series of data points all the way on the bottom left corner, right? So that's a little bit odd. So that's one thing that's odd, but kind of overall with that odd thing, what is some of the things you guys might be noticing in this particular graph?
It looks like there's a pretty strong relationship because all the points seem to be clustered around where there'd be like a straight line.
Very good. So you can kind of already imagine drawing that regression line kind of going through those scattered dots, right? Except maybe those kind of odd, possibly outliers in the right lower left corner. Okay, so it could be some kind of upward trend, possibly. Jada said the shape of the dots to me. What about the shape of the dots? Oh, they just look weird. Oh, well, I think you might be looking at the ones where there's kind of like two dots, like clustered, they're kind of close enough. So if the circles were kind of smaller and they're more like a really like small dot, they might not like overlap too much. But because it was done with a certain circumference, it might like look like that. So this might look a little bit odd compared to that one, but I think that's because there's like two dots there, okay? So anyway, so these are some of the kind of like maybe outliers possibly there, but overall Ariana made a good point that we might be able to kind of imagine this line going through these data points, a regression line in particular, right? The statistical relationship, not a deterministic relationship, because it seems like there might be a trend. We might see, it seems like there could be a strong correlation. And from just kind of like the basic knowledge you might have of this world, it makes sense that if a dress item or like a clothing item has a high retail price, it might be likely that the rental price could be a little bit higher too, right? So there could be this upward trend. All right. So what we're going to do is next class, we're going to convert this over to a spreadsheet, which I've already done. And then what we're going to do is we are going to kind of figure out that regression line based on like the stuff that we know and some other equations that we're going to learn. And then we're going to make some predictions. That's what we're going to go for. Okay. I won't make this a homework. We'll actually do this in class next time. Okay, so just know that that's coming and we'll start there next time. Any questions before I let you guys go?
I have a question.
Yep.
So on Blackboard, it said that problem set 8 was due, but I don't think you mentioned that in class. So like,
I totally forgot about the problem set. Okay, well, if I didn't mention it, don't worry about it. I'll probably assign it for, oh God, that's gonna, did anybody open it up and start it?
yeah, I finished it.
Okay.
I didn't know how to do one question, so I was gonna ask for help, but then you never talked about it, so I wasn't sure if I should.
Okay, so everybody besides Ariana, don't worry about it for, God, now it's gonna give you all kinds of weird numbers, isn't it? Yeah, I totally messed that one up. I was supposed to assign that earlier, but I didn't. But I won't because obviously I didn't remember it this time either. Okay, so go ahead and start it if you want, which is, let me just double check. It was problem set 8, right? Correct? Oh, it is the HP means. Oh, we should do that. God, it's this semester. Okay, so go ahead and do that. I'll give you plenty of time. If you did not do it, because I didn't mention it in class, I won't take off any points for being late, guys, okay? So just go ahead and do it. It is very likely that it's now gonna show up as just practice problem status, as opposed to, you know, actually getting graded. Remember the default thing is that ungraded attempts or whatever the terminology they use. Go ahead and do that, it's fine. This is for hypothesis testing. Oh, it should have been HT means too. So even the title is wrong. So go ahead and do that at your own pace. Try to finish it by this week, or I'll give you the weekend as well. So don't worry about the deadline. Just go ahead and do it. And then just, again, don't worry about the grade that pops up on Blackboard.
Are you okay,
anyway.
Professor?
No, I'm not okay. I hate Lumen. I love Lumen and I hate Lumen. Oh, God, it's a love-hate relationship. Anyways, I can't believe I messed that one up again. All right. But just know that that's one of the things you guys should do, okay? But other than that, take your time to do it. Don't worry about anything else, okay? All right. Have a good weekend. Oh, no. I'll see you Friday. Come to class Friday.
All right. Thank you, Professor.
Thank you.
Just to be double clear, there's nothing due on Friday, right?
There's nothing due on Friday, okay? But please start problems at 8, okay? At your earliest convenience.
All right.
Okay.
Thank you.
Thank you, Professor. Bye.
Bye. Ay.
Professor, can I get help with this one question?
Sure. Let me just open it up.
Okay.
Give me 1 second. It should take me like 2 seconds. It's problems at 8 you're talking about, right?
Yeah.
Okay, let me just, here we go. Direct me to the question number.
So there's this question, it's number 12.
So is it something, remember the numbers might be a little bit different. Is it a researcher has boiled her hypothesis test down? Is that one?
Yeah.
Okay. Okay, find the p-value. Okay, so let's see. I can do it really quickly. So it looks like you have the X bar and the sample standard deviation, right? So we're going to do the T critical value. So if I were to do that quickly, T equals, my number is 44 for mu. What's your mu?
Mine is 41. For
Okay.
your alpha value, what is it?
Output value? Oh, alpha value, it's 0.06. You got something that's not 0.05?
Yeah, I didn't know how to do it because like every site I looked at, they only did increments of 0.5 and mine is 0.9.
Yes,
So
yes, okay. Actually, don't worry about that question. Let me address that to the entire class so we can do that together, okay?
Okay.
Yeah, I actually, now that you pointed out, I remember that I was gonna say this in class and then assign the problem set. And of course I forgot. So yeah, just forget about that question for now and I will show you how to do that next class, okay?
Okay, thank you.
All right. Bye.
Bye.